Let's talk about polynomial long division. Before we do the example at the bottom of your screen here, I just want to look at the top and explain when you need to do this and why. So first, the difference between a proper rational function and an improper rational. So a rational function is always a polynomial divided by another polynomial. So proper is when the degree of the top polynomial is less than the degree of the bottom. Sometimes we could call this like a bottom heavy rational function. It's improper if they have the same degree or if the degree on top is larger. So the method of partial fractions that we're learning only works if it's a proper rational that you're starting with. So if you start with an integrand that's an improper rational, you just need to change it around using the method we'll talk about here, and then you can use the method of partial fractions the way that we learn it in class. So the example that I have here is 3x cubed plus 2x squared plus 5x minus 3 divided by x squared minus 1. We can see the degree of the top polynomial is 3, the degree of the bottom is 2, so this is improper. All right, so we're going to do polynomial long division to rewrite this in a different format. So I'm going to say x squared minus 1 divided into that top polynomial. And I'm setting this up just like old school long division, which you probably haven't done in a decade or so. Technically, this is all the same. So we're going to build our answer up top here. And then we're actually going to end with a remainder, which again is not something you probably had to think about in a really long time. Okay, so the key is to focus on the first term here, the x squared, and just the first term here, 3x cubed. So we think, okay, what do I multiply x squared by to match 3x cubed? I need a 3 and I need an extra x. So I'm going to write 3x up here as the beginning of my answer polynomial. So if I multiply 3x times this x squared, it'll perfectly match the first term here. That's what I want. All right, so what I'm actually going to do now is multiply 3x times this whole polynomial. So it's going to distribute in and also hit the 1. All right, so I get 3x cubed. I'm going to write it right underneath here. And then minus 3x. I'm actually going to put the minus 3x not right next to the 3x cubed, but I'm going to shift it so it's underneath the 5x, just so like terms are vertically stacked. So I want to subtract what I've just computed from my top polynomial. So I'm going to subtract the whole thing in parentheses. The parentheses are really important here for the sign of the other term here. All right, so 3x cubed minus 3x cubed is 0. 2x squared minus, it has nobody, so just 2x squared results down here. And then I have 5x. This double negative makes a positive, so this is 5x plus 3x is 8x. And I'm going to carry down this minus 3. Okay, and now we're going to repeat the process. We'll go back to the x squared and think, well, what does x squared need to multiply by to match this 2x squared right here? We're just worried about matching this first term. Here it just needs a times 2, a positive 2. So I'm going to put plus 2 here, and I'm building my resultant up here. And again, I'm going to multiply now this 2 through this entire x squared minus 1, so it hits the first and second term. I get 2x squared minus 2, 2x squared minus 2. And again, I'm leaving this empty space just so that like terms are stacked. The reason I have to do that in this problem is because this polynomial doesn't have an x term. If it did, we wouldn't have this shifting issue. Right? So again, I'm going to subtract this polynomial from the one above it. 2x squared minus 2x squared perfectly cancels because we made that happen. 8x minus nothing is 8x. And then negative 3 plus 2 is going to give me negative 1. So I'm actually done with the long division at this point. I can tell that I'm done because the degree here, 1, is less than the degree here. So there's nothing I can multiply this by to match this. So this is my remainder. Remainder 8x minus 1. Okay, so now let's glue this all together. So we're doing all of this imagining that this is our integrand in an integration problem. So we need to rewrite this as a combination of what just happened. All right, so what we're going to do is always the answer plus the remainder over the original denominator. I'm actually going to write that down on the side before I do it. It's always the answer plus the remainder over the original denominator. Original denominator meaning what was on the bottom of the function you started with. Okay, so I have the answer, which was my 3x plus 2, plus the remainder over the original denominator. Oops, that wasn't a -1, that was a +1. There we go. All right, so now if I'm going to do partial fractions, everything is good to go. So 3x plus 2, I could integrate just as is, that's no problem. And this is a proper rational where I could continue with the methods of this section.